Okay, so yesterday we did example 1, and for example 1, I think some of you might have written it on example 2, but that was the wrong place to write it, or at least Jesus wrote it on the wrong place. That was the answer for example 1. Maybe just Jesus. Yes. Oh, sorry, Hayden.
I just saw 7% and 7% of 4,000.
Yeah, it's the same problem almost. Okay. All right.
Wait, Paul wrote it down in the wrong place too.
Oh wait. Okay.
We put it on example 2.
Yeah.
We did it too.
Yeah. All right. Example 1 was on the very first slide, so you may have written stuff down on example 2 that you weren't supposed to write down on example 2 yet.
I'm going to put an arrow.
Okay. And I want you to compare example 1 and example 2, because one of the best things that you can do when you're investing money is if the longer you leave your money in the account, the more money you will make. So here, Ty is the one who invested the $4,000. We want to know how much money he'll have in 4 years. So in 4 years, he had $5,243.18. So that's a pretty good return. He didn't have to do anything for that money. It just sat there and grew for him. So he got like $1,200 in 4 years. So pretty good there. But let's consider that example 2 here. So Ty's parents, let's say they put $4,000 in an account gaining 7% interest compounded annually when he was born. How much money would be in the account by the time he is 18? Okay? So in this case, remember with our exponential equations, it's y equals a times b to the x power. A is the initial value, so that is still $4,000. Okay? Remember for the b, we're going to take 100%. We're going to add the rate, which is 7%, which gives us 107. And then we've got to change that to a decimal, so we get 1.07, really just like sales tax. Okay? So 1.07. And that'll be to the x power. So this is the equation that we can use for any amount of years. We want to know after 18 years. Okay, so all we got to do is plug in an 18 for that x. So we'll be doing 4,000 times 1.07 to the 18th power. And so if we grab our calculator and do 4,000 times 1.07 to the 18th power. Now, Ty has okay, so Ty has $13,519, and we'll round that to cents, 73 cents. Okay, so if that money's invested early, then rather than getting $1,200 like you got after 4 years, now you're getting nearly almost $10,000, right? $9,500. So your money is over tripling in that time. Okay? This is why they will tell you that if you can save money early, that you will end up with a lot more. So if you're trying to save money for retirement, it's best to put more money in early if you can. Problem is, most people don't make as much money when they first start working as they do whenever they're older. They might not have as much extra money. If you can save money for your children's school early, like this, if you put this money, then you've got a lot more later on. But you got to put it in early for it to have more time to grow. You also hope the stock market doesn't crash and you lose all of your money. But It would just depend on the situation.
If you see it crashing, can you take out the money?
Okay, so let's look at another problem. Let's see. There we go. Okay. Okay. So we invest $10,000 in an account that gets 5% interest compounded annually. How much money will be in the account after 12 years? So it's the same thing again. Y equals A times B to the X. So, Evan, what is our A? What is our initial value? The 10,000. And then we've got to find our B. So, Cole, how do we find the B?
It's something with you add it with 100 or something.
Okay,
Like
100%.
then you make it like 1.05. Right?
Good. So we add 100 plus that 5, which gives us 105. And then we change it to a percent. And you don't have to write this down. I'm just doing it to make sure we're clear on where we get that. And then so we'll get 1.05 is our B. Oh, look at this. Just moved right over there on the top. Okay. All right. The X up here is always time. So it's the amount of time. So if we're compounded annually, then it's the number of years. So what number would we put there, Aiden? Aiden? 12. Okay. All right. So we just have to type this into the calculator. 10,000 times 1.05 to the 12th power. And if we do that, we're going to get 17,958. 0.56. Okay. All right, questions? All right, let's look at another example. Okay? This is a different context. So another time you see exponential growth is with a lot of things to do with science, specifically things like bacteria and viruses. So a sample in a lab contains 25 bacteria. The bacteria increase by 150% each hour. How many bacteria are in the sample after 1 day? Okay, so it's the same idea, but we have to, our B is going to be just a little bit different. Okay, so A for this, Gabe, what's our A? What's our initial value? 25. Now we've got to find B. Okay, now this is what sort of throws students for a loop sometimes, is that you do the same thing each time to find B. So a lot of students want to go ahead and just put 1.5 right here, because 150 would be 1.5 if you change it to a decimal. But you must do 100% plus 150%, which gives you 250%. Which is 2.5. So we would have to multiply by 2.5 here. Okay, you always start with 100. Anytime it tells you a growth rate, you always start with 100% because that growth is on top of the 100% you already have. Right? Kind of like sales tax, we have to pay 100% of that price plus the extra 7%. So we start with that 100. So if we have a growth rate, this is what we're going to do here. So 25 times 2.5. What do I raise this to? I heard 1, I heard 24. Which one's right?
Probably 24.
Okay. The growth rate is each hour. So that means the time that we plug in needs to be hours. 1 day is 24 hours. Okay, so we have to plug in 24. So 25 times 2.5 to the 24th power. Oh my, this is bad. Okay. All right, so what this is scientific notation. So you got 8.881784197. And this is like times 10 to the 10th power here. So we've got, with scientific notation, that means that we've got to move the decimal 10 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to put a 0 in that last spot. So good gracious, we've got 8, 8, 4, 1, 9, 7, 0. Oh my. Let's see, what is that? This is million, billion, 88 billion something bacteria. I think that the numbers of bacteria that are actually in your body are really, really high. So, and this is how you get sick so quickly. So if you get the flu or you get strep throat, you might just come into contact with a few little bacteria or a few little pieces of the virus, and then it starts multiplying really, really quickly. And so you go from having just this teeny tiny bit to in the bed with a fever, can't get out pretty quickly. Okay. I am not sure what number of bacteria there would be. You definitely can die from bacterial infections. You'll go septic, where your just whole body is sort of infected and they can't kill it. But I don't know what. This might be a small number in the world of bacteria because, you know, they're so teeny tiny you can't really see them. I'm not sure. It'd be something good for us to look up later. Okay. All right. Population growth is another place where we might see something like this. So the population of Elkin is 4,106. If the population grows at a rate of 0.4% per year, what will the population of Elkin be in 30 years? Okay. So exponential growth model, y equals a times b to the x. So Ian, what's our a? Very good. And then we've got to find the b right here. So Hayden, what will we do to find that b? What do we always start with? What's 100%? So we start with 100%. And then since this is growth, we're going to add the rate that we're increasing by. So that's 0.4%. Right? So 100 plus 0.4%, that gives us 100.4%. And then Hayden, what will we do to change that to a decimal? It already has a decimal, so that seems like a confusing question, right? But this is a percent because it's got the percent sign. So percent means per 100, divide by 100. You got to move that decimal 2 places to the left. So that's a mistake I see a lot of students make, is if it's already got that decimal, students don't move it. But you always got to move that decimal 2 places to the left. So you'll have 1.004. So 1.004. And then our x up here is a time. Hayden, what's our time for this? What number would we plug in for that? The 30 years. So we'll put the 30 right here. And 30 is what we plug in because this is the growth per year. And this is years. You want that to match. So if that was like growth per month, then we'd have to change that to months. But these match, so we just plug the number in. So now all you got to do is type it in.
It's like 4,000.
All right, so 4,628.30. 4.39. What does it make sense to round to on this problem? Nearest whole number. So 4, 6, 2, 8. There. People. Because this is people, it makes sense to round to the nearest whole person. Still a whole person. My dad had his right arm amputated whenever he was 17. He's still a whole person. Even though he only has a nub for his right arm. He has, he's like 60, almost 60 now, so it was over 40 years ago. So prosthetics were not very good. He does have like this like fake arm with a hook, like a pirate. But he doesn't ever really use it much, except for he works like on motorcycles and cars and stuff a lot. So he sometimes uses it for that if he needs like to carry something he can't carry with one arm. But he doesn't use it very much. He's learned how to do almost everything with just one arm. Really? Yeah, prosthetics have came a long way though. Like if you lost your arm today, they can do a lot more with prosthetics. So, but he's learned how to do most everything. There's very few things he can't really do well, just one-handed. He doesn't do well at a buffet. You have to fix his plate for him because he can't hold his plate and scoop food out. If they got a tray, right, like if they got the tray where you slide your plate down, he's fine. But huh? Well, he does have like a nub, so like if he can just hold it and twist it with his hand. So he can drive a bulldozer. He can drive like straight gear cars. He can do all kinds. It was his right arm, and he was right-handed. He was 17 when he lost it. Yeah. So had cancer, so I had to amputate it. Had bone cancer, so. All right.
You can play kickball with your bump. You can't like open doors unless it's one of the other doors. No, is it like a twisty one? Nah, dude. I tried to do it.
It'd be hard. Okay. All right. Last example. All right. So Roxana gets 2 rabbits for Christmas. One's a boy and one's a girl. This is the problem. The rabbits reproduce approximately every 60 days. If the number of rabbits triples every 60 days, about how many rabbits will Roxana have by next Christmas? Okay? Did anybody in here go to Freeman's Daycare? Freeman's Daycare.
I would have had some.
Anyway, at Freeman's Daycare is where my oldest son went. It's on Austin Trap Hill Road. It's just a small daycare. And Calvin, Miss Dory's husband, he had rabbits. And he would have just a couple rabbits, and you'd see him hopping around. And then there'd be more rabbits and more rabbits and more rabbits until you drive up and there would be like 15 rabbits just hopping around. The kids loved them. You had to watch the rabbits. But then sometimes I think the dogs and the coyotes and stuff would get them. And then the rabbit population would decrease. But rabbits reproduce really quickly. They are going to be able to reproduce roughly every 60 days. So instead of like a human that's pregnant for 9 months, rabbits every 60 days. No, they usually have more than one, I think. Do you have rabbits, Tristan? Do y'all raise rabbits? Huh? Not anymore, but you used to have some? Yeah. So, okay, that's not real life. Okay, so, if you get 2 rabbits, and you get a boy and a girl, and you put them in the cage together, and neither one of them are fixed, then you're going to have more than 2 rabbits probably before long. So let's say that that you get these 2 rabbits and you just let them multiply and you feed them well and you keep them where the dogs can't kill them and the coyotes can't get them, and you just want all of these little baby rabbits that you love so much. So, if this happens, okay, we are starting off, we're doing y equals a times b to the x power. We start off with 2 rabbits. Okay? Yes. We're just going to say the number of rabbits triples. So that simplifies it a little bit. Whereas if we say like each pair of rabbits has 3 babies or something, that makes it a little tougher because then you got to pair the rabbits back up. So we're just going to say the number of rabbits is tripling each time. That makes it a little bit easier. Now, when you see this, the number of rabbits triples, you do not have to do the 100% plus something because that's not a rate. It's the factor you're multiplying by. So this is your B. So our B is 3 here. Okay, so that is your B. You're not going to add it to. It's actually a 200% increase if you're talking about percentage increases. We'll talk about that more. So, now this is what I'm not really sure about. What goes here for my time? It's not 60. So, how often do they reproduce? 60 days. Okay? So I need to figure out how many 60-day periods that I've got here, right? So 365 days, and I'm going to divide that by 60. So I get 6.083 repeating. So I guess I could use that. It says about how many. So let's just use 6 here. That's pretty close to 6. Okay? So, because you've got 6 60-day periods or a little bit more. So, 2 times. No, you've got 6 breeding periods. So, like, it takes 60 days for them to have the first litter of rabbits. Then, after another 60 days, all those rabbits are going to have more rabbits. And then after that, 60. So, you got 6 periods that they can reproduce. So, if we do this, 2 times 3 to the 6th power, Roxana, at the end of the year, has 1,458 rabbits. It's a lot of rabbits. If you get 2 rabbits, make sure they're both boys or both girls. Or if you've got a boy and a girl, keep them in separate cages. Good for the bunny population. Now, in reality, in the real world, there are factors that cause these bunnies not to be able to reproduce. So if we were talking about in the wild, these bunnies might reproduce in this way, but you've also got predators that are killing the rabbits that keep their population in check. There might not be enough food. There's lots of different things that would keep rabbits from just taking over the world. If this were the case. But if you took really good care of them and made sure none of them died. Really? It's about this, about the exponential growth of rabbits. If I can find a video. Also, human population, guys. Human population works this way as well. If 2 people have 2 children, then they're just replacing themselves. There's no population growth. Everything just stays the same. But if 2 people have more than 2 children, then that causes population growth, right? Other people might make up for it by only having 1 child or no children at all, so they are not replaced. But if you are in a country where everybody is having many children. For example, if you go back to the 1800s, 1900s, whenever most people lived on farms and had 15 kids, or at least, 7 or 8, then you are talking about Tristan's family, and you were talking about major population growth. So that's how whenever you had people come over to the United States, it was just a few people, and of course spread until the whole United States was very populated now. Okay, so humans populate in the same way, although not quite as quickly as rabbits. All right.